battery or cells. So you might have seen all these cells or batteries. Normally these are cells and their voltage is 1.5 volt per cell. Dry cell. We usually use it for remotes, various purposes we use, or a flashlight uses this. And if you see here, these are the lead acid battery. That means usually we will get a voltage of 12 volt. It's 12 volt batteries. It's not exactly 12 volt batteries because when a cell is fully charged, the voltage varies, and when it discharges also, voltage varies. So this 12 volt lead acid battery voltage vary from 12 volt to 13.8 volt. It can, when it discharges, it goes to 11 volt, even 11 volt. This is the internal diagram of a internal construction of this lead acid battery. If you see here, there are number of cells are connected together. Now we will go to the definitions. We have seen what is a battery and what is a cell. Now let's go to the definitions. What's a battery? A battery is a group of cells. It's a group of cells. See here, this is a battery, and this we can see here number of plates are there. Those plates are the anode and cathode. They are together called electrodes, and there is an electrolyte also. So a battery is a group of cells. Now you might be thinking, then what is a cell? What is a cell? What is a cell? Cell is a single unit device. A single unit device. A single unit device which converts chemical energy to electrical energy. So what is a cell? It's a single unit device and which converts chemical energy to electrical energy. But always this is not the case. Why I say it is not always the case? Because we have a solar cell also. Solar cell, what we get? From light we will get the electrical energy. Okay, this is in the scenario of batteries. Now, one more thing is there. What is there? This, to make the batteries, we can do it in a different ways. To make a battery, how do you do? We are using the cells to form a battery, but there are three methods we can use to form a battery. We can connect the cells in series. Second, we can connect the cells in parallel, and finally we can connect it in series parallel combination as per the requirement. Series parallel combination. Because whatever the battery we need, usually it will be higher voltage or the higher age than the single cell. That's why we make these combinations. And today we are going to learn about cells connected in series. Cells connected in series. Now, this is a cell. This is a symbol of cell, and all cells will have some internal resistance. This is the internal resistance R, and this is the first cell E1. All this is the second cell and its internal resistance. Next, I'll take one more cell we have to draw. So this is the third cell. What the internal resistance? Again, the one more cell, four cell. Four cells are connected in series. These are their internal resistance. This E1 is a E2 cell, second cell, third cell, potential difference. E3, okay? E3, E4. These are the potential differences. And all these are 1.5 volt. Assume that all are 1.5 volt. And all these cells are 1.5 volt. And their internal resistance. Now I think we need not worry about the value. Now, after making the cell combination, series combination of cells, this is our terminal. Why do we use these cells, these batteries? To drive a load. So this is our load resistor. Take it as R. Now we'll see what is the, now if you see what is the total voltage. That means you have to add up all this ET. ET is the total voltage or EMF, total EMF when batteries are connected in series. That is E1 plus E2 plus E3 plus E4. If you add all these four, we will get. But these all cells are equal voltage. So I can write ET equals N multiplied by the E. N multiplied by E, voltage of a single cell. E is the voltage of a single cell. Now what is the total resistance of the circuit? RT, total resistance. Total resistance of the circuit, which equals, we have the load resistance R. Now we have to take care of the internal resistance of the cells. So here all cells are having same internal resistance, because to make a battery usually we use the same cells. So we have 4 batteries. So I'll write it as generally N multiplied by R. This is the total internal resistance. Now what is the current flowing through circuit? What is the current flowing through the circuit? That is I. Total current. Total current flowing through the circuit. What is total current? I equals, what is the V by R? We are going to apply the Ohm's law. What is the V here? ET, that is the total voltage. Voltage across the terminal. Upon total, what is the total resistance? R plus NR. This is the total resistance. Now this is equal to what? I. Already I wrote, this is I. So these 3 equations we should know. That is our total. What is the total EMF when cells are connected in series? Next is, what is the total resistance? And finally, what is the current flowing through this circuit? Now what we do, we will solve one simple problem so that we can understand it better. So this is the given problem. 4 cells of 1.5 volt EMF and 0.5 ohm internal resistance are connected in series to a load resistor of 5 ohm. Calculate the total circuit current, total voltage drop, and terminal voltage. Now, let's make the circuit. Internal resistance, I will draw it together. I am not drawing separate. I'll draw it, I'll replace with a single resistor. So 4 cells we have. So third cell, fourth cell. So all are 1.5 volt. Right, 1.5 volt. All are 1.5 volt. Internal resistance. So internal resistance equal to N multiplied by R. What is the N here? We have 4 cells. So 4 multiplied by, what is the value of R internal resistance? 0.4. So this will give us 1.6 ohms. So I'll write this is the internal resistance, 1.6 ohms is the NR. Now we made the battery using the cells. Now what is the terminal voltage? At the terminal, what we are going to do? Terminal, we are connecting the load. That is our R. What is the value of R? R is given as 5 ohms. Now, first we will find the what is the current internal, what is the total current through the circuit. So what is the equation for I? I equals total EMF upon R, load resistance plus internal resistance, N into R. What is the total? Total 4 batteries are connected. So 1.5 multiplied by 4 upon, what is the value of our load resistor? That is 5. 5 plus NR already we found, internal resistance, that is 1.6 ohms. So this is equal to 6 volt upon 6.6 ohm. So what do we get? We get it as 0.909 amps. It comes to 0.909 amps. Now total current we found. What we need, what is next is what is the internal voltage drop. Where this voltage drop, here we have to find what is the voltage drop happening. When the circuit is closed, load is connected, what is the voltage drop? We have to find. How do you find? It is easy. We are equal to voltage drop equal to total circuit I into R. R is the what? Internal resistance, that is N multiplied by R. I we know 0.909 amps multiplied by R. What is the value of R? 1.6 ohm. This comes to 1.45 volt. So 1.45 volt is getting dropped across the internal resistance of the battery. Now what else we have to find? Terminal voltage. Now if 1.45 volt is dropping across the internal resistance here, it is dropping here, correct? Then what is the, it is dropping here, 1.45. What is the terminal voltage? That is the terminal voltage. Terminal voltage. Terminal voltage equals total EMF. That is ET minus VR. What is the value of ET? ET we know it was 6. 6 minus 6 volt. Okay. Minus 1.45 volt, which equals 4.55 volt. So we have learned what is a cell and how to connect in series and what are the related equations. Thanks for watching.